Welcome to my channel. Your tutor Mariam is here. It's a 64th video of Introductory Physics 1 and the 26th video I'm going to talk about the laws of motion. That is the fifth subject of Introductory Physics 1. In this video, I'm going to solve an example which is similar to the previous example. In this example, I'm going to change units just to bring up the attention that units matter. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. Here I have two blocks are in the contact. For the first part, force applied to block B, and for the second part, force applied to block A. And I need to find the contact force between two blocks. I'm going to start with part A. So let's think about it this way. If force applied to block B, then block A and B start to move together, right? So I can assume they behave as one object, right? So I'm gonna write the second Newton's law. Based on the second Newton's law, F total gonna be equal to sum of the F, right? That's telling me it's gonna be MA plus MB, remember they move together, times A equal to 6 newtons, right? So now if I add 400 plus 200 times A, it's gonna be 6, and based on this equation, I can find the acceleration right here, right? So this guy gonna be 600. However, it's in gram, right? That's a point you guys need to pay attention. So if you're writing down the second Newton's law, your mass must be in kilograms, not grams. So here I need to do the unit conversion. So we already know 1 kilogram is equal to 1000 grams, right? So I need to use this to do the unit conversion. I talked about this in the previous videos, and I'm going to put a link below. Feel free to check them out. So now I'm going to convert 600 grams to kilograms, right? So remember the rules, grams and grams must be cancelled out. So grams must be in denominator, so they can cancel out. 1000 grams is equal to 1 kilograms. So what I left with is kilograms, right? So now if I do the little math, then this guy gonna be 0.6 kilograms, right? And this is the one I should use in my calculation to find the acceleration here. Now I'm gonna write it down again. So again, F total gonna be equal to 0.6 times acceleration equal to 6, right? And then my acceleration here gonna be 10 meter per second square. And that's gonna be my total acceleration here. Now I have total acceleration and I can find the contact force between two blocks. Let me draw the free body diagram for block B. So block B has one force, which is F, and also have a contact force from block A, right? I'm going to call it as AB, from A to B. Now, if I write the second Newton's law, then my F total for B gonna be equal to sum of F, right? And then that's gonna be F minus FAB equal to MB times acceleration, right? So remember we're talking about object B here, right? So mass should be B, but acceleration gonna be the total acceleration. I just found it because they move together, right? If they move together, then acceleration for block A and B gonna be equal, right? Which is equal to the total acceleration. So now my F gonna be 6 minus, I'm looking for FAB, equal to MB. Again, remember I have to do the unit conversion here. So I'm gonna put it as MB till I find it, and also my acceleration gonna be 10. Now let me do the unit conversion for MB. So again, 1 kilograms equal to 1000 gram, right? So here I have 400 grams, right? So that's gonna be gram, that's gonna be 1 kilogram. So I have 1 kilogram, so it's gonna be 1, and I have 1000 here, so it's gonna be 1000. Why I put 1000 in denominator? Because this gram and gram must cancel out, right? So if I do the little math, that's gonna be 0.4 kilograms, right? And this is what I should substitute here. So I'm gonna write it again. This is gonna be 6 minus FAB equal to zero point 0.4 times 10, right? And then that's telling me my FAB gonna be equal to 2 newtons. And that's gonna be my final answer for part A. Now let me calculate part B. Let me write down the second Newton's law for object A. So that's gonna be F total A gonna be equal to ma times acceleration, right? And free body diagram for A at this point gonna be F in this way, right? And also there is another force from B to A, right? So I explained it in the previous video by the direction of FBA are in the opposite side of the F, because object B is trying to stop A from moving. So it's like a barrier here. That's why the force is in the negative direction. So then that's gonna be equal to FBA minus F. Again, let me do the unit conversion. That's gonna be 200 grams times is gonna be 1000 grams, 1 kilograms. So this is gonna be 0.2 kilograms, right? And then I have 0.2 times 10 equal to FBA minus 6 newtons, right? So if I do the math, my FBA gonna be equal to 8 newtons. And that's gonna be my final answer for part B. Again, my purpose of solving this example is bring up the attention that units matter. So if you have a homework solving the problems exam, always pay attention to the units. You might need to do the unit conversion and it change your answer. I hope you find this video helpful. If you like my video, hit the like button and subscribe, and I'll see you in the next video.